Hello and welcome. In this video tutorial, we're going to take a look at the solutions to Unit 7, Lesson 3 on intersecting chords. Please remember to pause and rewind the video as necessary. Let's begin. Now in part 1, in question 1, we are supposed to use a measurement device. We're supposed to use a ruler to measure each of the segments to the nearest millimeter. I'm going to help you out with this because I don't know how many of you actually have a ruler available to you at home. But I'm going to break these chords. There's two chords, A, B, and C, D. Now I'm going to break them down into 4 segments, and I'll color code them. A, E is the black chord right here. This is the black segment. B, E is the blue segment. D, E is the yellow segment right here. And C, E is the gray segment right here. So using a ruler to make these measurements, I approximated them to be about 27 millimeters for AE, 28 millimeters for BE, 22 millimeters for DE, and about 35 millimeters for CE. And so if I take the product of AE and BE, I get about 756 square millimeters. Millimeters times millimeters is square millimeters. And then if I multiply these two together, CE times DE, I get about 770 square millimeters. So I wanted to at least help you guys out with part A, since I don't know how many of you guys have a ruler available to you. Part B, you simply multiply AB times BE and then DE times CE. Now, part C, how closely do these measurements agree with the theoretical relationship? Well, the theoretical relationship is that this segment times this segment equals this segment times this segment. Well, they're pretty close. They are pretty close. So we can say that they are fairly close. Any small errors in measurement would account for the difference. Question 2. Circle K, diameter TW, intersects chord RS at point X right here, such that the measure of SW, arc SW, is 38 degrees. So let's find SW. SW is this arc here, okay? And that measures out to be 38 degrees. Now remember, ladies and gentlemen, an arc is measured from a central angle. So if we were to measure that central angle, it would be 38 degrees, and the arc mirrors that angle, central angle measurement. We're also told the measure of arc WR is 98 degrees. So let's find WR. I'm going to color code that one in blue. WR would be this one here. And from a central angle, that one would measure out to be 98 degrees. So if we drew a line from here and here, that would measure out to be 98 degrees. Okay. Now it says, which of the following represents the measure of W angle WXS? Well, WXS is this angle right here. It's WXS. It's that angle right there, which is the same as this angle here. They're vertical angles. Okay, but what I need to be able to do this, to make this calculation, angle WXS, which is the interior angle right here, is going to be the sum of my arcs that intercept it. So the sum of this arc and this arc. Now I don't know this one, so I got to find it. So it's going to be the measure of arc RT plus SW divided by 2, but I don't know RT, so I got to figure that out. Well, you can figure out RT pretty easily because the whole line right here adds up to 180. This is all 180. So if this is 98, then that means RT is going to be 180 minus 98, which is 82. So now I can figure out angle WXS, which is the same as angle RXT. Both of them are the same angles. And that would be 82 degrees plus 38 degrees divided by 2. And we get about 60 degrees, which you can see is option number 2. Number 3, in the circle M shown, chords GH and EF intersect at point K such that EK, I'm going to darken these in. So EK is this segment here. That would be 5 units. And FK, which is this segment here, is 6 units. Now GK, which is that segment right there, that is 3 units. We want to find the length of GH, which is that full chord right across. Now, in order to do that, you're going to need to find the length of this gray segment KH. We got to find that first. So we're going to find, we're going to find KH first. We could do that by setting together the idea that this segment times this segment equals this segment times that segment. So we're going to set our products equal to each other. So EK times FK equals GK times HK, or KH, whichever you want to call it. And so you're looking to find KH. So to do that, you need to divide by GK, both sides. And then let's plug in our numbers. So KH would be equal to 5 times 6 divided by 3. Well, 5 times 6 is 30, divided by 3 is, of course, 10. Okay, but you can see that GH would be the sum of GK plus KH. It's the yellow and the gray added together, which would be 3 plus 10, or 13. Number 4. In the diagram of circle O, angle NQM is equal to 103. So this angle right here is 103. Okay. If the measure of LP is 30 degrees more than the measure of MN, so LP is this one here. LP is that one right there. If that is 30 degrees more than the measure of this blue arc, MN, determine the measure of MN. Okay, so here's what we need to know. We need to know that this interior angle 103 is equal to both of the intersecting arcs added together divided by 2. So it's MN plus LP divided by 2. And we already know what LP is. So 103 is equal to MN, which is what we're looking for, plus LP, which was, now it was 30 more. 30 more. So what we're going to do is we're going to let X equal MN. And then what's going to happen is 30 plus X, which is 30 more than MN, that's going to equal LP. So we could rewrite this as 103 equals MN, which is X, plus LP, which is 30 plus X. All of that is over 2. Well, we're going to go ahead and multiply by 2 to get rid of the fraction. And so far we have 206 is equal to x plus x, which is 2x, plus 30. Go ahead and subtract 30 both sides. And we get 2x is equal to 206 minus 30, which is 176. Divide by 2, and mn, which is x, is equal to 88 degrees. Number 5, circle A has a radius of 9 units. Circle R lies 5 units away from A. A chord drawn through R is partitioned by the diameter of A, passing R into 2 segments, one of which has a length of 7 units. Is the length of the other segment longer or shorter than 7 units? Justify your answer. Well, first, let's draw this. It's kind of hard to visualize. So we've got circle A, so A is in the center. Let's draw a diameter across like this. Draw a diameter across. And the radius is 9 units. And we have another chord that's going to be intersecting at point R right here. And we were told that point R is 5 units away from A. So that's 5, and this has to be 4 because 4 plus 5 has to equal the other radius. We were told that this segment is broken down so that this is 7 units. And we want to find out, is this greater or less than 7 units? Well, we'll call this missing one x right here. So we're going to go 7 times x, that's this segment times this segment equals this segment times this segment. So 7 times x equals 9, not 9, 9 plus 5 is 14, times that segment, which is 4. So 7x equals 14 times 4, which is 56. X equals 8. The other segment is longer. Than 7. In question number 8, diameter CD is perpendicular to chord AB as shown. Radius OB and OA are drawn. How can we prove that triangle OEB is congruent to OEA? Well, we could use HL, which is hypotenuse leg theorem. And the way that works is this is a radius, this is a radius, so those two are equal. OE is a common leg that is equal to both triangles. And if 2 legs out of 3 legs are the same, then the third leg must be the same as well. And therefore, triangle OEB is congruent to triangle OEA. What does this tell you about the segments AE and BE? Well, since OA is congruent to OB and OE, segment OE is equal for both triangles, then AE is congruent to BE. And lastly, if the diameter is 20 and CE is 4, what is the length of AB? So CE, the diameter is 20 all the way across, but CE specifically is 4. That means this remaining segment, of course, has to be 16. It says determine the length of AB all the way across. Well, the way we'll do this is we'll go CE times DE equals AE times BE. Okay, and we're going to look for AE, BE. Now, AE and BE is the same as AE squared. Those are the same unit. So essentially, we'll write this as CE times DE equals x times x, or x squared. And then we'll square root both sides, and x is equal to CE, which is 4, times DE, which is 16, the square root of which is 64. That means x, which is AB and BE, would both equal 8. So that means that segment AB has to be 8 times 2, or 60. Okay, I hope you found this video tutorial helpful. Again, please make sure to pause and rewind the video as necessary. Thank you.